class, I wanted to go over one of your labs that you will be doing at home. The lab is called Faster Plop, Plop, Fizz, Fizz, and it's over the scientific method. Make sure you pull the lab online and print it out. So you will have the procedures and the material available to you. So let's first start with the materials that you need to gather in order to do your science lab. So the first materials, and I'm on page 6 of the procedure, is the Alka-Seltzer tablets, the 5 packs, and they are included in the materials kit. So I wanted to pull that out for you. So in the kit, it'll look in a bag like this, and it says Carolina Faster Plop Plop Fizz Fizz, a scientific method investigation. And the Alka-Seltzer tablets are in that bag. So that's in the materials kit. And then from the equipment kit, there's a separate bag labeled Principles of Chemistry Equipment Set. You need to pull out the 250 milliliter beaker. So this is the 250 milliliter beaker. It's plastic. Okay. The thermometer. Okay, so the thermometer is in this plastic sleeve. I have the thermometer down here. So it's the thermometer in the sleeve. Okay. A wax pencil. That's the black wax pencil. And 6 plastic cups. So these are just the clear plastic cups that come in the kits. Okay. You also need, from the chemistry safety set, you will need goggles. So these are the types of goggles that come in your kit. Please wear them to protect your eyes. I'm wearing my safety glasses. Okay. Now there are additional supplies that aren't included in your kit that you will need. A medium-sized bowl or glass to make an ice water bath. So here's my ice water bath. I just used a clear bowl. You're going to need ice, okay, hot tap water, a stopwatch or your cell phone or a kitchen timer. So I have my stopwatch here. It's just a kitchen timer, okay. You'll also need, as I recommended in one of my safety videos, the fire extinguisher. So today's lab should not involve any fire or have any concern with that, but I just wanted to point out that make sure you have purchased a fire extinguisher. Okay. Wear gloves. There are gloves in your safety or in your chemistry safety set. So I'm wearing my gloves. And now I'm in my kitchen, so I wanted to kind of present this in more of the home environment like you will be doing your labs. So you need to make sure that you're not eating or drinking or chewing gum while you're performing the experiment. Make sure that the Alka-Seltzer, so Alka-Seltzer contains aspirin, and you need to make sure you keep these out of reach from children and pets, because that can not be very good if they get a hold of that. Okay. And I've just prepared an area in my kitchen. I cleaned everything up. I washed my hands before I started. So now we're going to start the activity. Okay, so I'm on page 7, activity 1, and I'm just going to walk through some of this with you, and then some of it you can do on your own, but there's some important features in the lab that I want to address. So activity 1, part A, temperature versus time to dissolve. So part one, you're setting up your experiment. So you're going to get 3 of the clear cups. So I have them here. And with the wax marker or pencil, the wax pencil, you're going to label one of the cups with an H for hot, one of the cups with a C for cold, and one of them with RT for room temperature. Okay? You're going to need to make your ice bath. So I added water, well, I added ice, and then I added water. And I added 300 milliliters of cold water. So on step 3, it says make an ice bath by adding ice and at least 300 milliliters cold water to a bowl or cup. And I wanted to go over that. So your beaker measures up to 250 mils, okay? And how you read a beaker is you get your water, put it on my sink, and you add the water up to 250. Now to really read the beaker, you need to have it on a countertop, and you need to have your eyes right at the level of the water so you can read it accurately. So I'm going to squat down, and I'm going to have my eyes right at the level of the water. So my level is a little bit over 250, so I'm going to dump some out. Okay. And now read it. Okay, so now it's right at the water level is right at the 250 mark. So I've already done this, but then I would add 250 to the ice, 250 milliliters. But we need 300. So after you add that, you need to add 50 more milliliters to be 300. I added 50. I'm going to be eye level with the beaker. I'm a little bit over 50, so I'm going to pour some out. Still a little bit over. Pour some out. And then eye level. Okay, so now I'm right at 50. So I'd add that to my ice. Okay, so that's how you read a beaker. Okay, so then they talk about opening the Alka-Seltzer packages. And with a scissors or a knife, score each side of the tablet into equal halves. So I've already done that, but I wanted to show you. So sometimes they kind of fracture. And I'll bring them closer. So I took my knife and I scored down the center and made a score mark, and then gently pressed the tablet. And they divided in half. Now some of the pieces, so I'm going to move over here. Some of the ends somewhat, if you can see, fractured. Like this has a separate piece. So I just make sure that I keep any pieces that break off together, okay? So that the amount of the tablet stays the same that we're adding to the water, okay? All right. So you carefully break the Alka-Seltzer tablets into halves. And then we're going to start adding our water to the cups, okay? So using your beaker, your 250 ml beaker, you're going to measure 200 milliliters of room temperature tap water and pour it in the cup labeled RT for room temperature. Okay, so I have already added water to my cup labeled RT. Okay, and I've placed the thermometer in the cup, all right? Because we're going to be measuring the temperature. Okay, then you are to, so now I'm on page 8, step 8, you're going to add 250 mils of hot water in the H cup. So you're going to get water out of your sink with the hot tap water, okay? And then you're going to need to get 200 milliliters of the ice, cold water from the ice bath, but we're not going to include any ice in the cup, okay? And then we're going to record the temperature of each of the 3 cups. So I'm going to get my water heated up to hot, and I'm going to start, while that heats up, I'm going to add 200 milliliters of my cold water, and I'm not going to add any ice. In fact, what I might do is I'm going to remove the ice chunks from my ice bath. Okay, because we don't want it to keep dissolving. We want the temperature to know what it is. This is like how it's going to be when you're at home doing your experiment. Okay, so all the ice is removed, and I'm going to pour this water to 200. Water's getting hot over here in the sink. So this is the ice cold water. Again, I'm going to lower my ice to the beaker. Okay, put it on the countertop. All right, I'm still a little bit over. So you want it right at the 200 mark. Okay. So this is 200 milliliters of cold water. Okay. Now I'm going to rinse this off to kind of get it to temperature, since I had just ice cold water in there. So now I'm going to add 200 milliliters of hot water to the cup that's labeled H for hot. Okay, I'm going to get to eye level. I'm a little bit over. Okay, so that's 200 milliliters of hot water. So now we're going to measure the temperature of each of the cups. So I wanted to go over measuring the thermometer. So this thermometer is in degrees Celsius. And, okay, so you'll see this when you get your thermometer out. So the graduations on this thermometer is by 1 degree, okay? So it starts at negative 10 degrees Celsius and goes all the way up to 110 degrees Celsius with the markings, incremental markings at per 1 degree. So that means that we can measure the temperature to the 10th. Okay, so like I'm reading my thermometer, so you're going to read the red line at where it is against the white background. Okay, so this is at the 23. Okay, it's at 23, but it's a little bit past the 23. It's not to 24 degrees. And so I'm going to estimate the last digit. And that's like what we went over with significant figures in our Chapter 2 lecture. So this is going to be 23.5 degrees Celsius. I'm going to try to bring the thermometer a little bit closer so you can see how that looks. Okay, so I'm going to record that temperature on my data table. Now I'm going to place the thermometer in the cold cup for a few minutes and let it come to temperature. Okay, so you got to let it equilibrate, meaning that it needs time to actually decrease the temperature and measure the accurate temperature of your solution, which is the cold water. Okay, so we're going to take just a couple minutes to let it stabilize. Okay, let's see if it's moving any. Still moving a little bit. So the bottom part, the bottom bulb part, is what's measuring the temperature. So you want to make sure you leave the bottom part always in the solution as it's coming, as you're measuring. So this is, let's see, 6.0 degrees Celsius for the cold water. So, okay, now I'm going to put it in the hot water. So I'm going to record this on data table 1, 6.0 degrees Celsius. The room temperature was 23.5 degrees Celsius. Now we're going to measure the temperature of the hot water. Okay. All right. Let's see. So this increased because it's hot. It's a higher temperature. So it's still increasing. Okay, so this is stabilized and it's equilibrated to 51. It's right at the line, so 51.0 degrees Celsius for the hot. 51.0 degrees Celsius. Okay. So I'm going to remove the thermometer. I'm going to wipe it off. I'm going to put it back in that plastic sleeve so it doesn't break. So I'll have it for other experiments that we're going to do during this semester. Okay, so I just put it back in its sleeve. Okay, so now we're going to run the experiment. And what we're going to do is we're going to start with the cold cup, then the room temperature, and then the hot water. And we're going to time the amount of time that it takes for the Alka-Seltzer tablet to dissolve. Okay, so I'm going to start with the cold cup, and when I place it in, I'm going to start the timer, and we're going to record how many seconds it takes for it to dissolve. Okay, so I hit start. And it's fizzing and producing lots of bubbles. So whenever you are doing an experiment, you need to record what you're observing. So in observations, I'm going to put sank to the bottom, bubbles formed. Okay. We're going to see how long it takes for this to dissolve. And in this lab, the question that we are trying to answer is how fast does an Alka-Seltzer tablet dissolve in water at different temperatures? So we are dissolving a tablet, half of a tablet, in different temperature of water, to see how that affects the amount of time that takes the tablet to dissolve. Okay, so in science experiments with using the scientific method, there are different variables throughout the experiment. So and there's three different types of variables: independent variable, dependent variable, and controlled variable. Okay, and so within this experiment, okay, so let me make sure. So it's almost dissolved. Okay, just a little bit more. Okay. Okay, so it's dissolved. So we're going to stop the timer. So that was 2 minutes and 12 seconds. Okay, so I recorded that on my data table 1. All right, so I'm going to clear this. All right, now we're going to do it at the room temperature. Okay, so the minute I put it in, I'm going to hit start. Okay, so this was the cold water, so it took 2 minutes and 12 seconds. And now the room temperature. Tablet, it's still, I'm observing bubbles, and it also sank to the bottom. Bubbles formed. And you know, it seems like this tablet, okay, this tablet dissolved much quicker. Okay, so we're going to stop it. All right, that only took 46 seconds. 46 seconds to dissolve. Okay, now I'm going to clear it. Now I'm going to drop a tablet in for the hot water. Okay, I started my timer. Oh, this has rapid bubbles. All right, I'm going to make sure that I get this stopped right when it stops fizzing. Okay, almost. Okay, it is stopped at 22 seconds. Okay, so now you're going to discard the solution down the drain, okay? And you're going to rinse the cups out. And you're going to complete part 3, which is repeating, doing the same thing. You're going to repeat part 2 for 2 additional trials. So you're going to do this same thing that I just did 2 more times. So we're going to have a total of 3 runs. And if you'll see in data table 1, you have run 2, where you're going to have the cold water, the room temperature, and the hot water. Run 3, cold water, room temperature, and hot water. And you're going to collect that data. Then you're going to average, do an average for the cold, for the room temperature, and the hot. So an average is you add up all the variables. So you're going to add up the cold temperature for run 1, the cold temperature for run 2, the cold temperature for run 3. Add those together and divide by 3, because there's 3 variables. Okay? And the same thing for room temperature. You'll do the same thing and then fill in the average. And then for hot, you'll do the same thing and get your average. Okay? And also do that for your time. So you're going to get the average for the temperature and the time in seconds. Okay? Then, okay, we're going to talk just a second about the scientific method. So let's think about this. In the scientific method, you have 3 different variables. So one of the variables is called independent variable, and this is explained in detail on page 4. But the independent variable is basically the factor that you're altering and you're changing, and it is controlled by the investigator or the scientist. Some examples are, like they said, time, temperature, concentration, pH, and pressure. So in our experiment for the independent variable, what did we change? What have we changed in this experiment? Okay. Did we change the type of medicine? No. Did we change the amount of the medicine? No. We had half a tablet. We had different temperatures of water in our experiment. So the temperature of the water is the independent variable. That is what we altered. Okay? And we altered it because we want to see if temperature affects the amount of time it takes for the Alka-Seltzer to dissolve. So the dependent variable is what depends on the independent variable to change. Okay? So our independent variable was the temperature of the water. The dependent variable was the amount of time, the rate at which the tablet dissolved. Okay? The hotter the temperature, the quicker the tablet dissolved. Okay? So the dependent variable was the time or the rate at which the Alka-Seltzer dissolved. Okay? Another variable is called control variables. And these are the variables that are consistent. They stay the same. We are not altering them. So think a minute about some things as you watched me do this experiment that I left the same. So, okay, I'm going to try to see if you can compare this. Okay. So the amount of water was the same, right? We added 200 milliliters of water. So the amount of water was a controlled variable. It was the same. Another thing that we left the same was the amount of the medicine. Each cup had half a tablet of Alka-Seltzer. Now, if you only put like a corner in one of these, it's going to change the rate. So, and then you won't be able to make accurate conclusions because you have altered and made too many independent variables. Okay? So the control variables were the amount of water and the size or the amount of the medicine. Okay? So you're going to finish part 3 and do your 2 additional trials. So you'll do 3 trials total. Okay? And then you're going to test. Okay, so now I'm on page 10. Well, I'm sorry. Page 9. Okay? So you're going to complete activity 2 after you've completed activity 1. Okay? I'm just going to kind of walk through that. Okay? On activity 2, part A, it's testing the new hypothesis. Okay? It says preparation. You're going to list 5 questions about the rate at which the Alka-Seltzer tablets dissolve. Think about the control variables and what would happen if temperature were held constant and one of the controlled variables was changed. Okay? You're going to have to think about that. Okay? So then you're going to develop a new hypothesis based on one of the questions. Remember that a hypothesis must be testable with empirical or measurable data. So you're going to have an experiment that you can measure data with, okay? So you'll see activity table 2. Okay, you're going to state the hypothesis, identify your independent variable, identify the dependent variable, list the control variables, and then you're going to answer the question, how will the dependent variable be measured? So that's what you're going to measure, okay? and then describe the expected results if the hypothesis is true. Okay, so you're going to answer those questions. All right. So once you've answered the questions, now let's talk about this just for a minute. Let's think about things that you could change. So before, our independent variable was the temperature of the water, but this time, and there's all different things that you can do with this experiment, but I just kind of want to talk through this a little bit. So another way you could perform this experiment using the independent variable is just using a different amount of medicine, different amount of the Alka-Seltzer, while leaving the temperature of the water the same and the amount of the water the same. So the amount of water and the temperature of the water would be controlled variables. So the dependent variables would be the rate or the speed at which the Alka-Seltzer dissolves. But that's something that you can measure with your stopwatch. But you could change the amount of the medicine and keep the temperature the same. So you could use a large piece. You could even use a whole tablet. And then in another one, you could use maybe just a fourth. But it would have to be measured. So you would have to cut the tablet in a whole tablet, maybe a half a tablet, maybe a fourth of a tablet. Okay, so you're going to, on page 10, you're going to test your hypothesis. You're going to design a procedure. You're going to test it. And you're going to describe exactly what you did. So you're going to write a procedure down for me, and then you're going to perform your experiment, and you're going to record your data in data table 2, okay, on page 10. So you're developing your own experiment. And then the disposal and cleanup for this lab is you're going to dispose of all the solid waste generated. You can just put it in the trash. You can put all the liquid in the sink, okay? And you keep your cup. So you just put this down the sink, wash and dry it out, and save it for other experiments, okay? So you don't have to really have any special disposal methods. You just want to make sure all your equipment is clean and dry and ready for the next experiment. I hope this was helpful. Please email me, call or text me with any questions. I hope you enjoy this lab, and I hope it helps you become more familiar with the scientific method. I look forward to seeing you guys on another video soon. Bye.